Welcome back to ACER Explained. I'm going through section 3 of the ACER Practice Question booklet, and in this video, I'm going through Unit 14. So Unit 14 is a bit of a long one. It has questions 36 to 39, and as always, I'll be identifying any prereq knowledge that you might have needed, reasoning skills that could be used, and some bootcamp resources as well. So starting off by taking a look at Unit 14, it's also quite intimidating, like the last unit as well. We are given the cellular respiration equation, and then we're also given kind of the process of glucose being turned into fructose, and then glyceraldehyde, pyruvic acid, going into citric acid, oxalosuccinic acid, alpha-ketogluteric acid, succinic acid, and then going down to fumaric acid, malic acid, and oxaloacetic acid. So if you don't have the booklet in front of you, I would highly recommend bringing that in front of you now so that you're able to follow along, because this one's a bit more visual. But for question 36, you'll find very quickly that you don't need too much information. Question 36 is just asking which of the following are a pair of structural isomers. So structural isomers are essentially two molecules that have the same molecular formula but have a different structure. So you need to have the same number of carbons, oxygens, and hydrogens in this case. And so when you go back and you compare, for example, starting off with glucose and fructose, when you compare the structures and formulae of these two, you'll realize that they actually share the same molecular formula. It's just arranged in a slightly different way. And so you can immediately, figure out that A is your correct answer. But let's go and compare the others as well. So when you're comparing citric acid with oxalosuccinic acid, and you are counting your carbons and hydrogens, etc., you see that there's one hydrogen that's missing, so that doesn't share the same molecular formula. Then when you go to fumaric acid and compare that to oxaloacetic acid, you see that the formula is, again, it's quite different. So if you count the carbons in fumaric acid, you have 1, 2, 3, 4 carbons. You have 1, 2, 3, 4 oxygens. And you have 4 hydrogens as well. But when you go to oxaloacetic acid, you count the carbons and you have 4 carbons. You count the oxygens and there's 5 oxygens, and so immediately it's not it's not the same molecular formula. And you do the same thing for oxalosuccinic and oxaloacetic acid. So starting with oxalosuccinic, we have 6 carbons there. Then we have 7 oxygens, and we have 5 or 6 hydrogens. Then with oxaloacetic acid, we have the same as before. We have 4 carbons, so immediately that's eliminated because that's a different number of carbons. So yeah, if you were really unsure, then you would go through and do these. But once you figured out that it's A, for the sake of time in the GAMSAT, I would just circle it and move on. So for this question, you needed to know a little bit about what structural isomers actually are. And so for that, we have a bridging course and content in action. We have organic chemistry bridging course and the stereoisomerism content in action. And then also we used kind of the process of elimination as well as pattern recognition, because it's pretty much just counting carbons, hydrogens, and oxygens. So once you can recognize that, then it becomes a lot easier. So question 37 is asking us about empirical formulas. It's asking which of the following has the same empirical formula out of these 4 pairs. So empirical formula, this is basically the simplified ratio of your molecular formula. So say you have fructose, so you have C6H12O6. So this is just pretend this is a random molecule. The empirical formula for this is going to be CH2O, because you can divide all of these by 6, right? And then this is your simplest ratio that you're left with. So what you're going to do is you're going to basically go through and count all of the carbons, hydrogens, and oxygens that are given to you. And that's going to give you the molecular formula. So for fructose, when you count the carbons, hydrogens, and oxygens, you have C6H12O6. And for succinic acid, when you do the same thing, you're going to get C4H6O4. When you do the same thing for glucose, you're going to get the same as fructose. So you're going to get C6H12O6. And then when you do the same thing for glyceraldehyde, you're going to get C3H6O3. So I'm going to continue doing this and then I'll come back. So there you go. We have all of the different molecular formula on the screen now. But you don't actually have to keep going after this point, because when you get to this point, you can already tell that the ratio of carbon to hydrogen to oxygen is the same in glucose and glyceraldehyde. So when you when you simplify them to their empirical formulas, you get CH2O if you're dividing each number by 6 for glucose. And then for glyceraldehyde, you're dividing each number by 3 and you get CH. 2O as well. And so these are the same empirical formula. So then you have B as your correct answer option. So for this question, you just needed to know what an empirical formula is. You could potentially get away with kind of like guessing what it is after you've written it out and trying to just look for a pattern that kind of matches between the two molecules in each answer option. And you're using the process of elimination here as well. And that pattern recognition comes in to like just taking a look at glucose and glyceraldehyde. You can already see, you don't really have to reduce it to the empirical formula. You can already see that they have the same ratio. So you can just circle the answer and move on so you don't have to waste your time. And we have the reasoning skills course for that, as well as the specific acceleration class for pattern recognition, and then also the bridging course on organic chemistry to become more familiar with things like empirical formulas. All right, so this next question is asking us about what kind of reaction changes fumaric acid to malic acid, okay? So I've put the molecular formulas here. You would figure that out just by counting the carbons, hydrogens, and oxygens like we've been doing before. And basically, I'm going to write it out in kind of an equation form and leave some space as well so we can fill things in. H6O5. So this side is malic acid and this side is fumaric acid. Okay, then we're just going to see what the difference is on both sides. So over here we have the same number of carbons. Over here we have 2 extra hydrogens, so we need a plus H2, okay? And then we also have 1 extra oxygen. So we're just adding H2O. And so this is water. And that's kind of common knowledge. That's something that you should know, that H2O is the formula for water. So because you're adding water, the answer option, out of the answer options, the only one that makes sense is a hydration reaction. So yeah, the answer is C, and that's kind of how you figure that out. You don't really need to know too much about like the details of this reaction, but it's just more of a reasoning kind of thing. So you don't really need to have too much prereq knowledge other than your kind of basic chemistry reactions. It's definitely useful to be familiar with your basic chemistry reactions, especially with organic chemistry, so that you're able to work through these kinds of questions more quickly because you're already familiar with them. But it was also using pattern recognition in order to kind of figure out what's going on. If you've never seen these molecules before, you need to figure out like, okay, well, I'm going to take a look at what's different between the two molecules and therefore figure out what kind of reaction is required to make one molecule from the other. So that's pattern recognition skills. And so that's in our reasoning skills course as well as our pattern recognition acceleration class. But to get familiar with the organic chemistry is quite important as well. So we have the bridging courses there, as well as our content in action for some kind of extension stuff as well in the bootcamp. Question 39 is asking us about a new artificial sweetener. And the only thing you really need to know is that the way that this new sweetener is being created is by replacing all of these hydroxyl groups that are attached to the ring. So not this one here. All of these hydroxyl groups that are attached to the ring of glucose, so I've drawn out the glucose molecule here, they're replaced by chlorine atoms. So I'm going to draw that out here. So we have CH2OH. This hydroxyl group is left alone because it's not attached to the ring. But I'm just going to draw this out quickly. We have, this is now chlorine, this is now chlorine, this is now chlorine, and this is now chlorine, okay? And so we already know that the empirical formula is C6H12O6 for glucose because we've done it in the previous questions, but I'm just drawing it out for completeness. I'm also going to draw out now all the hydrogens so we can have an easier time counting. So hydrogen here, one here, and one here. So let's start off by counting the number of carbons. So we have 1, 2, 3, 4, 5, 6. So we have C6. And then we have the hydrogens. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have H8. Then counting the chlorines, 1, 2, 3, 4 chlorines. And then finally the oxygens, we have 1, 2 oxygens, O2. And this is the molecular formula. To find the empirical formula, we need to simplify it. So we can divide it by 2. So we get C3H4, Cl2, and O. And that gives us our answer option C. But we didn't actually have to do all of this. If we kind of just figured out, okay, well, these OHs are being replaced by chlorines. We know that there's 4 chlorines. So we know that there's going to be 4 chlorines added to this molecular formula. We know that no carbons are being touched, but we have 4 hydrogens that are being lost and 4 oxygens that are being lost. So you just minus that. So 12 minus 4 is 8, and then 6 minus 4 is 2. So that you don't have to draw it out and count it completely. And you'd get the same molecular formula, and then you'd do the final step of converting it into the empirical formula like that. And for this question, again, you needed to know what an empirical formula is. Even if you didn't, you could still kind of infer if you got the answer and then you're like, okay, well, this doesn't match anything. There's this option that is kind of like the same ratios, so maybe this is the right answer. You can still deduce that using that kind of a reasoning. And you did need some pattern recognition and especially the interpretation of the question because you needed to understand what the question was asking of you. It can seem quite daunting, like, oh, it's being turned into this new sweetener. I don't know anything about that. But if you break it down, it's really not asking you to do anything too difficult. And so that's something that you can learn through the reasoning skills course, as well as the chunky text acceleration class as well, because this was quite a chunky one. But when we broke it down, the unit became quite straightforward. Then there's also the organic chemistry classes that I've been mentioning throughout this video as well, so that you can get a bit more familiar with organic chem so that it's not too daunting. But technically, you could have still answered these questions with minimal organic chemistry knowledge. So that's the end of Unit 14. Thank you so much for watching, and well done for following along if you've been following along from Unit 1. It's a bit of a stretch. There's a lot to get through, but you're doing really well. And so yeah, like, share, and subscribe for more GAMSAT help. We love your feedback. And we have our Instagram at ThankFlipGamSat, as well as our podcast, ThankFlipGamSat, Nurses Doing GAMSAT, if you want to hear more from us. But yeah, I'll see you in the next one.